Alright? So, bromine, the first question it says, predict if they will gain or lose electrons. So on your charge sheet, under the -1 column, you should see bromine. So bromine would be a -1 when it when it becomes charged. All right. So does that gain or lose an electron? Gains. So you should have gain on this one. Okay. Look up strontium. Strontium's under the +2 column. And so it would be a +2 when it becomes charged. So did that gain or lose?
Lose.
Okay, it would lose. And it would lose 2 electrons. Alright? When you find lead, lead's in two places. It's under the +2 column and it's under the +4 column. In either case, it's a +2 or +4, it's going to lose electrons. Arsenic arsenic isn't on our charge sheet, but if you look on the periodic table at the end, it says a -3. So that would gain 3 electrons. Sulfur is on our charge sheet. It's under the -2 column, and it's a -2, so that would gain electrons. And then krypton is not on our charge sheet, but it's on the periodic table, and it's 0. So it will not lose or gain electrons. So that's what its tendency would be, not to lose or gain electrons. Okay? That was for number 2. Number 3, for that one, it says for each element give the new charge of the atom based upon losing and gaining electrons. So bromine would be a -1 because it gained 1 electron. Strontium would be a +2. Lead would be a +2 or 4. Arsenic is a -3. Sulfur is a -2. And krypton does not have a charge. So it would be 0 for that one. Okay. For number 4, you're supposed to write down for each one of these if they were oxidized or reduced. So bromine, it's a -1. Was it oxidized or reduced? Reduced. Okay. For strontium, it was oxidized. Okay. So right here you have 2 different things happening. Bromine is going from this to this. So meaning it's gaining 1 electron. Okay? That's how you would show something being, if you wanted to show something gaining electrons, that's how you'd show it. Alright? Strontium, on the other hand, starts out neutral, then it goes SR +2 electrons. So if it's reduced, the electrons being added to it. If it's oxidized, electrons are taken away from it. So we've got this symbol that says oil rig. What does oil rig stand for? Oil is oxidation is losing electrons. And in the rig part of it, reduction is gaining electrons. That's a way you can remember again if you did forget. That's kind of how you differentiate between those 2. Okay? So lead was oxidized. Okay, arsenic was reduced. So if we would show those two, I just want to show a bunch of examples of these. So if I showed it plus 2, it'd be Pb. Where would the electron be? On the left or right side of the arrow? So would the electron show up if it's oxidized on the produced, or would it be added on the left side? So look at one that's oxidized here. It'd be the same as this one. So it'd be on the right side, right? Okay. And if I would show arsenic, because I'm going to have you do one of these here in a second. So if I show arsenic, okay, would the electrons be on the left or right side? If it's reduced, it'd be on the left. Because we're adding 3 electrons. Okay, you guys see the difference? These two here, this one here is reduced. This one's reduced, kind of showing it reduced. And then the other two are oxidized. So I'm going to have you guys do sulfur, see if you can show it right. So below number 4, show sulfur. Here's sulfur, what it turns into. We can't do the last one because the last one does not have a charge. So the last one is Kr and it's no charge. So go ahead and show what you think happens to sulfur. So that last one, if we showed sulfur, we'd show sulfur plus 2 electrons gives us sulfur minus 2. Is that what you guys had? Okay. So if we're adding electrons, it's reduced. If we're taking electrons out, that's oxidized. Okay? Any questions you guys have? I just got to thinking, I'm going to go back. Some of you had showed a chart. It was called activity table. If you guys get that activity table out, it looks like this. The activity table. Okay, I'm going to tie this into what we're just doing. Okay, so what's the most active element on your list? Lithium. Okay, lithium is number 1. Okay, and then gold is last. Okay, I'm going to ask you a question. Which one of these two, between lithium and gold, do you think is more likely to lose electrons? Lithium or gold? Lithium will. So lithium is more likely to give up electrons to become a +1 than gold. Okay, so gold's down here. And if we would show gold giving up electron, it would look like this. Okay? So lithium is more willing to give up its electron than gold. So that's why when you have a choice between which one's more active, lithium would be top on the list. And if you notice, gold, platinum, and silver at the bottom, they're least likely to give up electrons. So they're least likely to corrode. They're least likely to react. The top ones that are most likely to react would be these top 4 or 5. They're most likely to give up their electrons, and it doesn't take much to give up their electrons. Okay? All right, so what we're going to do is you need to write down if it was for each element number 1. Okay, we wrote that. Number 5A, we've already done that. I'm not going to have you do that. What I'm going to have you do is I'm going to have you use your chart. We're going to do the first 3. So you've got your chart sheet. Okay? What I want you to do is I want you to look these up and write their charges. Now, if an element is by itself, when it's not with something else, we're going to put a 0 above it. So is Na by itself?
No.
No, it's with chlorine, and chlorine's with sodium. So you got to write the charges for those two. Is bromine by itself?
Yes.
Yeah.
Okay, so if it's by itself, you're going to write a 0. So any element on those first 3, if you see them by themselves, you write a 0. Write a 0. And then anything that has a charge, write the charge right above it. So every element on that chart, I'm going to have you guys write a plus or minus charge above it. So do that for A, B, and C. Go ahead and write the charges down for A, B, and C. What you guys have? Anything you got wrong that you got questions on? Yes, Preston.
So, why is B, what's the difference between, B, like the first 2 on B?
HI, this one?
Yeah, and then
Okay,
There's H
MG's
and
by
then I.
itself.
H
And then I is a -1, and then H is a +1. On your chart, you can look on your chart, it should be a +1.
If they're by themselves, why are they 0?
I'll explain that here in a second.
So like on D, Fe would be just 0.
What's that?
On D.
We haven't done D. Oh, D is in letter D? Yeah, we'll do that here in a second. Okay, here's the thing. If I've got bromine by itself, and it's a liquid, I got some bromine in the back, and it hasn't reacted with anything, it takes on its natural number of electrons and protons. So bromine is element number 35. So this bromine here has 35 protons and 35 electrons, so it's neutral. Okay? It's not until it bonds with something then it's charged. This chlorine here, the Cl2, it has 17 protons and 17 electrons, so it's neutral. So anything I list by itself and I don't write a charge with it is neutral. Okay? Now, for the first one, what I want you to do is I want you to connect you're going to connect twice. I'll do the first one for you and you can do the next 2. So I'm going to connect chlorine because chlorine has changed its value from the left side to the right side. And then bromine has changed its value from the left side to the right side. So what I want you to do on B and C, I want you to connect those elements that change their value. And just kind of connect them together like I have shown on A. Go ahead and connect them together on B and C. Connect those together. Okay? Jordan, on B, which ones did you connect?
B.
Yep, letter B.
Okay. H. That's I.
Yeah, but which one of those did you connect? H or I?
H.
What'd you connect it to?
Other H.
Okay. And then what did you connect? What's the other one you connected?
MG.
MG. Okay. Austin, which ones did you connect on letter C? Okay. So these reactions we call oxidation, reduction reactions because you have two things happening for this reaction to take place. Something's being oxidized, something's being reduced. All right? I always pick out the one that's reduced because it's the easiest to recognize, I think. So, on this first example, which element is being reduced? Cl's going from a -1 to 0. Bromine's going from 0 to -1. So reduction would be what? Should be bromine going from Br to a -1. What's it doing? It's picking up an electron. It's being reduced. So it's going from Br, it's picking up one electron, and it's becoming Br -1. You guys see that? So what I would write here, I'm going to have you guys do that here in a second on these other ones. Write reduced. Bromine is being reduced. So out to the side you can put Br reduced. Okay? So if you pick right, the other one should make sense. Cl is going from a -1 to 0. So this is what's happened to Cl. Cl is going from a -1, okay, and then over here it's becoming Cl plus 1 electron. It's giving up its electron. So Cl is oxidized. So I'm going to have you do the next two. You don't have to show this part. Okay, so all you have to do is write down oxidized and reduced. So you don't have to show this part here. All you have to do is write down blank is reduced, blank is oxidized. So do the next two. Letter B. I like picking the one that's reduced. Okay? So I got a +1 going to a 0. So that's picking up an electron. You guys see that? For it to be a 0, it has to pick up a negative charge. So hydrogen is reduced. Okay? Magnesium's going from a 0 to a +1. It gave up its electron. Okay, I guess this should be a +2, shouldn't it? Yeah. So it gave up 2 electrons. So magnesium is oxidized. Okay? Okay, the last one, and then I'm going to have these do the last 3 on your own. Do all the steps, because I got a demonstration I got to show you guys. I showed the other class on Friday. So I'm going to pick out the one that's reduced first. See, aluminum goes from a +3 to 0. How many electrons did it gain? 3. Okay? So aluminum is reduced. Okay? Calcium is oxidized. Any questions? Okay, so while I set up this demonstration, you guys get the opportunity to do D, E, and F. When you guys do the nitrate, the NO3, do that all as one charge. Don't look up the nitrogen and oxygen separately. You should have a nitrate on there. So write the charges of everything on there. If it does not, and you guys already did this already probably, if it's by itself, it's 0. Then go ahead and connect them. Then write down what's reduced and oxidized on it. So if you did this right, 0, 0, plus 2, minus 2. Fe, oxidized. O, reduced. Questions? Got them? Zero to a minus 2, gained 2 electrons. 0 to a plus 2, lost those 2 electrons. Zinc goes from a 0 to a plus 2. So what is that? Zinc is what? Oxidized or reduced? Oxidized. Okay? Ag goes from plus 1 to 0. So it lost or it gained an electron. So silver is reduced. Last one. S goes from 0 to minus 2. So S is reduced. Goes from a 0 to a plus 2. Oxidized. Okay, we did 6 examples. Hold on to that for tomorrow, and you'll get a similar sheet you're going to have to do to start a class. So hold on to that.